All right, here we go with the first three examples off of your review for your test. So let's just dive in. When we're looking at this first guy, we just need to ask ourselves, all right, derivative of what will give us 7x to the negative fourth? And so this is a situation where we can add 1 to the exponent and divide by the new exponent. The other question we need to ask is derivative of what gives us cosecant squared x. And so we're using two different properties here, and that's okay because they're separated by a plus sign. Now, if this was 7x to the negative fourth times cosecant squared, we would have a different issue. So with this first guy, I've got 7x to the negative third divided by my new exponent, which is negative 3, plus, and then the antiderivative of cosecant squared is negative cotangent, and then plus c. So to finish this problem off, I would just move the negative on the bottom here to the front. And there's two ways. You can either leave the x as x to the negative third, or you can make it pretty. I prefer pretty, so it would write negative 7 over x cubed minus cotangent x plus c. So this is problem number 1. Problem number 2 now introduces a substitution, okay? Where, and we're told, hey, we've got, 3x minus 4 here, and we're going to let it be represented by this u. So anytime we make a u substitution with integration, we're going to take the derivative of this side. So du dx is equal to 3. And then we multiply both sides by dx so that we can get just du alone. All right. When we integrate this, what we're looking at is trying to figure out a situation to get some equality to work for us. For example, if I write down exactly what I've got right now, I've got the integral of 9 times u to the negative 3 dx. I cannot integrate this because I don't have the same variable all the way through. I've got a u in one spot and an x in another. But here's a dx right here. So if I can get this dx all by itself, and I'll divide both sides by 3, then what I end up with is 1/3 du equals dx, okay? And so when I have this situation, I've got an equality now where dx is equal to 1/3 du. So here's dx right here. I can put 1/3 du in its place. That takes me to my problem that I'm going to work, which is 9 times 1/3 times u to the negative 3 times du. Okay, so my 1/3 du, there it is right there, 1/3 du. My 9 here, my u to the negative third there. Any constant inside my integral can move to the front. So this becomes 3 times the integral of u to the negative 3 du. And now add 1 to the exponent and divide by the new exponent. 3 times u to the negative 2 over negative 2 plus c. The final step is to replace the u and make the exponent positive, which is going to give me negative 3 over 2 times u, and in this case that's 3x minus 4 to the negative 2 power. All right, so there's that guy. Not too bad, not too bad. Now this next one, number 3, he's a little bit different. And notice on this particular one, we've got u equals cotan 7x. So here's my u right here. U is equal to cotangent x. And so when I look at that guy, I'm going to replace u in. Also, if I have a u, I need to sort out what my derivative of the cotangent is going to be. And in this case, it's going to be cosecant squared of 7 theta times 7. And not only that, it's a negative. So just look on any sort of trig sheet that you want to look on, or cheat sheet or derivative sheet, and it's on there. And this is going to be d theta because that's the variable that we're working with. So let's just pause there and substitute and show what we've got. All right. So we're looking at a problem on the left, which is cosecant squared x, or cosecant 7 theta, times u times d theta. I've got u, I've got d theta, I've got 7 theta. I've got too many thetas running around. I need to get everything to u's. And if we come back and look at our u substitution over here, I can rewrite some of these things. Like here's a cosecant squared theta. I'm seeing a possibility here with this cosecant squared theta. So let's multiply both sides by d theta. So du equals negative 7 cosecant squared 7 theta times d theta. And let me clean this up a little bit so there's no question. All right, so here's cosecant 7 theta d theta. Here's cosecant squared 7 theta d theta. So let's go ahead and divide both sides by negative 7. Okay, and when I do that, that's my equality. Negative 1/7 du is equal to 7 cosecant squared theta d theta. I am now ready to integrate, and when I do that, I'm working with the integral of negative 1/7 times u times d theta. And this integral is comes out really, really easy. We're just going to add 1 to u and divide by the new exponent. So negative 1/7 times u squared over 2 plus c. And then we just substitute in what u is, which is this cotangent of 7 theta up here. So this is going to end up being negative 1/7. Let's go 1/14. Negative 1/14 times cotangent squared of 7 theta plus c. So there's your first 3 questions off your review, and they weren't horrible, but there are some substitutions in there. Pay attention so you can make sure that you get those substitutions right. The trick with that is to look for equality with your du's and d thetas or du's and dx's.